Section 7.5, adding and subtracting radical expressions. When two radical expressions have the same indices and radicands, they are said to be like radicals. Like radicals can be combined, added or subtracted, in much the same way that we combine like terms. And in this first problem here, we have square root on both of the radicals, and they both have the radicand of 5. You can think of this similar to how you would handle 3x plus 9x. We treat it the same way because of the condition of our like radicals. 3 plus 9 times the square root of 5, and in place of 3 plus 9, of course, we would put a 12 times the square root of 5. We can only simplify like radicals by combining them, and in this next example, although they all have the same indice, only the second and third term have the same radicand, making them the like or similar radicals. Those are the ones we can combine then. The coefficient on this first square root of 6 is an implied 1. We have a 1 minus 7, which will give us a minus 6 square root of 6, along with the 5 times the square root of 2. So 5 times the square root of 2, either plus a negative or just minus 6 times the square root of 6 is the simplification of that radical expression. On first inspection, this next example doesn't look like these are similar radicals, but our ability to simplify radical expressions can help us to find like radicals, even when at first it may appear that there are none. Square root of 2 we can't do anything with, but square root of 18 can be simplified. If we break 18 down into 2 times 9 and take the square root of each of those two, the result will be square root of 2 times the square root of 9. Simplifying that further then, and I am showing the steps and you may take some shortcuts. The 3 was the coefficient out in front of the radical. That's still there. Square root of 9 times the square root of 2 is equivalent to the square root of 18. But by breaking that up, square root of 9, since it's a perfect square, gives us 3. Square root of 2 we can't do anything with. But it simplifies it to a point of, if we multiply those coefficients, 3 times 3 is 9 times the square root of 2, we now have like radicals. They're both square root of 2, which allows us to combine those coefficients then for a final answer of negative 9, or try it again, negative 5 plus 9, which is going to give us a positive 4 times the square root of 2. Similarly, in this last example here, on first inspection, boy, they don't look anything like, but if we simplify 8 and break it down into a 4 times 2x, 50 could be thought of as a 25 times 2x, and simplify from there. First term, there's nothing to simplify in that radical. We have the 7, square root of 4 will bring out a 2, since square root of 4 is equivalent to 2 squared, leaving the 2x underneath the radical. Minus 5, square root of the first factor, square root of 25 is 5, and square root of 2x we can't simplify. Cleaning this up, we can go and do the multiplication next. 7 times 2 is 14 times the square root of 2x. Doing the next multiplication, 5 times 5 is 25 times the square root of 2x. And now if we look, we do have like or similar radicals. Each is a square root, each has the radicand 2x, and we can combine these. Following order of operations, left to right, 1 plus 14 would make 15 times the square root of 2x minus 25, and then we'll do the subtraction, the next operation to the left. 15 minus 25, or plus a negative 25, leaves us with a negative 10 square root of 2x.